Welcome students. We are back with another lesson. In this lesson we'll discuss accuracy and precision and errors in the measurement. So let's first discuss accuracy. Accuracy means how much your measured value is close to the actual value, the true value. So it can be defined as the closeness of a measurement to the true value of the physical quantity. Next is your precision. Precision means the resolution or the limit up to which the quantity can be measured. So to get a better picture, let's take an example. Suppose you are given a mass. Now this mass weighs exactly 0.52 grams. Fine. Now suppose I ask 3 students to measure this weight. This is my student A, student B and my student C. So first student A measured this weight. So this is the table for the student A. Now student A took this weight and measured it. He measured it on the weighing machine. The first value he got was 0.52 grams. The next he measured again and he got 0.51 grams. Then he measured third time and he got 0.50 grams. So he took the average of all the three measurements. He added these three values, divided it by the number of times he did the measurement. He did once, twice and thrice. So he added 0.52 plus 0.51 plus 0.5 will give us somewhere around 4.53. Okay, somewhere around 4.53. And then how many times he measured? 3 times. So divide by 4.53, divide by 5. Sorry, it won't be 4.5, it will be 1.5. Okay, 0.5 plus 0.5, this one will be 1.03. 1.03 plus 0.5 will be 1.53. Okay, now how many times he did the measurement? 3. So divide by 3. 1.53 divide by 3 will give us 0.51 grams. So he came back and he said that this weighing stone weighs 0.51 grams. Now you know the weight of this stone is how much? 0.52 grams. The first time he got it correct. But if you look at the second and third value, they are very far from the actual value. Can you see? 0.51 is lesser than 0.52. 0.50 is also very less than 0.52. So from his measurements we can conclude that since his measured value is not close to the accurate value, and how much is the accurate value? The accurate value is 0.52 grams. Fine. So I can say the measurements he made are not accurate. Fine. Now let's check the precision. Now first time he did the measurement, he got the closest limit was 0.52. He got this one correct. But in this case, the limit up to which he can measure is up to this second decimal, isn't it? Here he got the measurement wrong. And look here, in this third case also, he got the measurement 0. But you should get how much? 2. Fine. So his data are neither precise. These data is not close. Why? Because they vary very large. Okay, see here there's a difference of 0.1 grams. In the third measurement again he got 0.01 grams less. So his data are not precise also. So neither his answers matches with the actual value, so they are not accurate. And also he got the difference between the three measurements large. He's not getting the same value. Can you see? If he's not getting the same value means the measurements he are taking is not precise. Fine. So for student A, the measurement he took is neither accurate nor precise. Now let's consider for your student B. Now student B went and measured this stone. Now in the first case, she measured the weight and she got 0.516 gram. Again she measured and she got 0.515 grams. Again she measured, she got 0.514 grams. Now what she did, she added all these three values. So if you add 0.516 plus 0.515, somewhere around 1.031 plus 0.514, it will be somewhere around 1.545. Okay, now how many times she took the measurement? 3 times. So what she will do, divide that number by 3 and she will get 0.515 grams. Fine. Now she came and she reported that this stone weighs how much? 0.515 grams. Now let's look at her data. Now let us look at the first data. She got 0.516 grams, but you know the stone weighs how much? 0.52 grams. There is a very small difference. Difference of how much? 0.004 in the first case. Fine. So it is very close to the data but not that accurate. Similarly, consider the second case, 0.515 grams. This one, how much is the difference between these two? 0.005. Here also the data is very close to the actual value but it's not accurate. Consider this one. In this case also the data is very close. Okay, it is very close but it's not accurate. But if you compare the measurement of your student A and your student B, look in this case. The student A measured and he told how much? 0.51. But when student B measured, how much she got? 0.515. So I can say that the measurement made by your student B, okay, let's consider the average value. When student A measured, he got the average value 0.51 grams. When student B measured, she got 0.515 grams. So this is the actual value. Out of these two values, which is more closer to this actual value? The measurement done by your student B. Now what you notice is that, see, I can say that the data is not accurate. Okay, if I compare only student's B measurement, it's not accurate. But if I compare with the measurement of student A got 0.51 whereas student B got 0.515. So I can see the student B's data are very close to the actual value. So I can say that the measurement made by the student B is more accurate than your student A, but it is not correct. Fine. Now let's look at the precision. Now when she measured first time, she got 0.516 grams. When she measured second time, she got 0.515 grams. So they are approximately same. Can you see only the difference in this value? Here she got 5 whereas here she got 6. The difference of 0.001. Fine. Similarly, look here. Here she got 515 here and here she got 514. Again the difference of 0.001. So what I can say is that every time she took the measurement, the data are very close to each other. Unlike your student A, in case of student A, check the difference. How much is the difference? 0.01, which is very large as compared to this one. In this case, it is 0.001. Fine. So since there is very small difference between these three data, I can say she got a very precise data. Fine. Now let's consider the third case. Your student C came and measured your stone. Now first time he measured, he got 0.521 grams. The second time he measured, he got 0.520 grams. The third time he measured, he got 0.52 grams. And when he took the average value of all these three, he got 0.520 grams. Now here, what do you note is that the actual weight is how much? The actual weight is 0.520 grams. So in the first data, or let us, instead of considering this one, consider the average value. Consider the average mass when we'll check your accuracy. Now in case of accuracy, can you see he got the correct result? The stone weighs how much? 0.520 grams. The average mass he got is also 0.520 grams. So I can say his data are accurate. Accurate as compared to all of these three students. Can you see? He got this 0.52 grams. That's why I can say his data is accurate. The next, look here. In this case, how much is the order of difference he's getting? 0.01. Again here 0.01. The difference between these two is 0.001. And here he almost got the same value. So I can say he almost got the same result every time he did the measurement, isn't it? So I can say his data are precise. Therefore, the data presented by the student C is accurate as well as your precise. So this is your accuracy and this is your precision. If you still have any confusion with the accuracy and precision, please don't hesitate to ask. I will re-explain it to you again. Fine. Next, we will see if there are errors in the measurement. Can you see? Student A has made the error. Student B has made the error. So how can we measure the errors and remove the errors? To measure the errors and to remove the errors, what we have to do is we have to understand few formulas. The first one is your absolute mean. Absolute mean, denoted by A mean, is calculated as it will be the sum of all the measured value. Suppose this is A1, A2, A3 and so on. So what you will do to calculate the absolute mean, you will add all the measured values and you'll divide by the number of the values. How many times you took the measurement? 1, 2, 3. Fine. So this is how you will calculate your absolute mean. The next is your absolute error. To calculate your absolute error, what you will do is, suppose A bar is the true value. In this case, how much is the true value? 0.520 grams. So you will check how much difference is coming from the first measured value and the true value. The difference between the true value of the measured quantity and the individual measured value is known as your absolute error. Fine. So the measurement or the absolute error in your first measurement, what you will do, you will write the true value 0.520 grams, and then what you will do, you will subtract it from the measured value. Let us consider the second measured value. So subtract it from the second measured value. It is how much? 0.51 grams. So if you check the difference, that quantity will give us absolute error. Fine. Now after you calculated absolute error, we will find the mean of all the absolute error. That means we will add all this absolute error values and divide it by the number of the absolute values. How many absolute values are there? Fine. This is known as your mean absolute error. And then final one is your percentage error. To calculate your percentage error, what you will do is, suppose you have calculated the mean absolute error mean absolute error, you will divide it by the true value and then you will multiply with 100%. This will give us your percentage error. Fine. So on the basis of this, we will solve this example in our next class. Fine. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So again, thank you.